it's delivering the content. But because from time to time, these servers have to be are switched off, basically, either because they are found to be infected, or because they are found to serve infected content, or just because they were random machine hacked for this purpose, there will be some failed download attempts. Okay, so if we can detect one of these attempts, we can supply our own plugins instead of the real one. And so we call these plugins, specifically craft plugins, the red pill. So we give the malware a red pill instead of the original plugin. And when the malware executes that plugin, we do some real-time analysis. So we bring on the host, out of the blue, all the code that we need to run the analysis, or most of it. And we can basically perform an analysis with context, because we know everything about that process. It's running, so we don't need to wait the 20 minutes. It's distributed, so with one single point you can control the whole network. And to some extent, you can even, once you are really sure that what you are looking at is malware, you can even ask the red pill to shut it down. Boom. We'll see it later. So it's crazy, but it works. And one could wonder why this unusual combination. Well, the first thing is because I like anomaly-based stuff. So I like the concept that you detect things while they're happening. Like, for instance, you detect the failed download attempts. And then you can wonder, okay, let's just detect the failed download attempts. No, because it wouldn't work. If that would work, then flow-based network intrusion system would have already solved the problems years ago, and they didn't. And we also have to forget about peer-to-peer for a sec to apply this approach, because peer-to-peer basically will screw up flow-based intrusion detection system. So it doesn't work. Dot. There are years and years of research. There are some commercial implementation. They don't work. Well, they work up to a certain point. And then one could wonder, okay, let's do the other way around. Let's analyze every single download performed by my user. So in some countries, this could be illegal, by the way, I guess. In Italy, where I come from, is definitely legal. You will have a lot of problem with trade unions. But let's forget about, for a second, the legal issues, and imagine you are the system network manager of a 10-point-something network. You will never be able to do it manually or even automatically. It's not going to work, because you still have to provide the context. Even if you were able to do it for every single download, you still have to provide the context, and you still have to wait maybe the 20 minutes for the malware to activate. So we just go back to the problem of the usual DMA tools, right? So now Chris takes over. I'm done. I don't do any more technical stuff, so he did the technical stuff. He can tell you how the internals work.
So far we've seen the goals, we've seen the idea of Avatar, but we want to know how it works. I'm going to skip over the 3 logical components that we need here. First of all, we need something that detects the failed download attempt, which is of course the base of our whole idea. The purpose of this download detection engine is also to verify that what's being downloaded is a binary. And secondly, there's the red pill generator. This can operate in 2 modes. It can either just send a standalone red pill back without attaching itself to the original egg, which is what was supposed to be downloaded, or it's going to attach itself to this egg through PE injection. I'll show a bit later how that exactly works. And lastly, there's the malware analysis engine. This is receiving all the data from the red pill, analyzing it, and then sending a command back to the red pill what it should do. Should it terminate the spore? Should it allow execution? So that's the analysis part. We have a nice picture of how it works. The download detection engine and the red pill generator are together on one Linux box. We'll see that again in the live demonstration. So for practical reasons, we've done this in one Linux box, also to show it here. What you won't see is the IP tables rule. So the way we want to analyze all the downloads is having an IP tables rule that's rerouting all the traffic to an Apache module. This Apache module is doing the failed downloads checking if this number of failed download attempts is higher than a certain threshold. When it is, it's going to notify the red pill generator, which will then ship the red pill. And also here's where we do the binary checking, if it is really a binary. Right now we do this through checking the magic numbers, but they could bypass this. I'll mention that as well in the limitations. So the red pill, once it's executed on the host, it's going to try and open its own parent, which is the spore, first with the highest aces mask, which is process all aces. If it doesn't succeed, it's going to try a lower aces, right, until, well, the lowest fails. That doesn't really happen a lot. We've seen in our samples that almost all samples where we were able to open the parent, we opened it with process all aces. In that case, we can either freeze the process and we can terminate it. So actually containing the infection. Once the red pill is executed, it's going to gather as much information as possible from the parent. This information will be used to determine if this spore looks malicious. What I mean by that is, does it look like a program that's allowed to download and execute something? For instance, if the parent, so the spore, doesn't have a window, it's likely that it's not something legal, it's going to download and execute something. So the user probably didn't instruct this process to download and execute. The same with if it does have a window, it could be either very small or it could be off screen. It's all stuff we check, and based on that we say, okay, does it look legal or not? Then all of this information is encrypted and sent back to the malware analysis engine, which can also instruct the red pill to ship the spore back to the malware analysis engine so that it can be analyzed from the start. That's part of the malware analysis engine. This is a real box. It's still under development. It's a real box. There's no virtualization. So we avoid these countermeasurements against virtualization. It works with a kernel driver. It says here it's difficult to detect. Mostly kernel drivers are easy to detect, but because we own the system, we use rootkit technology to hide ourselves, basically. And also the techniques that are used against Anubis right now, that Damiano mentioned, like it's going to check on which user it's running, it's going to check in which folder. That will never be the same on our malware analysis engine. Or if they know what the serial number of our Windows installation is, we will hook these functions that the malware uses to request, for instance, the serial number, and we'll just spoof it. So we'll always get a different serial number from us. The same with the user and the folders being executed from. And we have ways to interact with, for instance, Malware. Let's say that our analysis isn't good enough. We can send it to Malware to have, well, a second opinion, basically. Our system has three ways to work in. Transparent mode, semi-transparent, and non-transparent. The first one is transparent mode, is the least intrusive. So once the DDE figures out that there are many failed download attempts, it's going to notify the RPG, which will ship itself back to the host, and only if the file is successfully downloaded. Because in this version, the red pill is attaching itself to the original egg. It's gluing itself. And once the red pill is executed, it's not freezing the parent initially. So it will allow the spore to continue executing. In the next mode, everything is the same except for the last part. Once the red pill executes, it's immediately pausing the spore. And then it's waiting on the verdict from the malware analysis engine to decide if it's going to allow the spore to continue to execute or not. And in the last non-transparent mode, we also straight suspend the spore, but instead of attaching ourselves to the egg, we send a standalone red pill. And once the malware analysis engine says, okay, this program looks legal, it's going to request, the red pill is going to request the original egg from the server and execute it. As with any approach, there are some limitations. The first and most obvious one is we use some static-based heuristics, namely the failed download attempts. What a malware could do is, well, of course, first, if there are no failed download attempts, then it's going to pass through. Unless you put your threshold on 0, well, then you're going to have a lot of legal applications as well that will be intercepted by us. And secondly, the malware could initiate the connections at a very low rate, like every 30 minutes doing one connection request. Then we're probably going to let it pass as well. Well, what the malware could also do is apply some verification, because it's of course going to download something, so it knows what it should expect. If it does some verification and sees that, well, this is not what I'm expecting to download, I'm not going to execute it, then we're not going to do our analysis, but we still stop the infection. And what we've seen from our samples is that none of the malware is actually doing this verification. If they would, it would be harder for them to update. What Damiano mentioned as well, if later they decide they want to seal credit cards instead of passwords, they need to update. Then they would need to update their hashes as well, which is probably something they're not going to do. But like I said, even if they do, we still stop the infection.
Yeah.
Yeah? Yeah, the question if there's typical executables that malware is downloading, you mean? Yeah. They're either downloading some executable or a DLL that they're loading. So we need to detect if it's an executable or a DLL, and based on that, ship the correct format back. Does that answer your question? What you also could do is use some steganography. They can hide in JPEG formats. I mentioned that before. We need to do some more checking if it is a binary. There was a talk here on Black Hat today about visualizing a binary. If you've seen that, then this is some technique that we could maybe use. Because then we don't rely on magic numbers anymore, but we basically rely on the entropy of a binary, of a downloaded content to check if it's a binary or if it's an image. And you can quite clearly see what's a binary and what's an image. And the thing I'm the most scared of, they can use create remote thread. So basically what a spore could do is inject a DLL into a legal process, say Internet Explorer or anything else. And then this DLL is going to download and execute the egg. What will happen then is we will intercept this, and our red pill will be executed, but we see Internet Explorer as the parent. So we're going to analyze Internet Explorer and probably allow the execution. But now we don't have a good solution for it. We're working on that. But also from the sample, we haven't seen any spore that's doing this at the moment, because I guess there's no reason to. But if they start doing it, it's a problem. Though it's only possible if they run, if the user runs as administrator. But well, on Windows, mostly people do anyway.
Okay.
So, showdown. Sorry, John.
Okay, so now we hope it works. If it doesn't, we have a movie.
It will work, don't worry.
I've seen so many demo failing there.
First of all, we're not online right now, so we had to create our own egg. Is this thing on? I don't hear myself. It is? Okay. So the egg is just hello world, I'm the originally downloaded content. And I'll first of all show that we have two virtual machines. This is the host, of course. and we have a Linux box.